class, you are welcome. In our last class, we explained the first three properties of binary operations. But today, we want to talk about distributive property, identity elements, and inverse elements. If you miss the first three, the explanation of the first three, lọ wo àwọn fídíò lára fídíò tá a ṣe kẹ́yìn lọ wo àti explain mẹ́tẹ̀ẹ̀ta yìí òkèlè. Kí ni a mean distributive property? Given a non-empty set S under a binary operation as steady and this for A, comma B to be a member of S. If there exists another element C which is also a member of S, then if A asterisk B cap C is equals to A asterisk B all cap A asterisk C, then we're going to say this thing is what? It is what? Left distributive. The asterisk is left distributive over cap. The asterisk is left distributive over cap. But by A asterisk B all cap C. To wáyé kí ni A cap C asterisk B cap C. That shows C, that means operation cap is right distributive over asterisk. Is right distributive over asterisk. For àpẹẹrẹ, addition, let me like this. Multiplication is always distributive over addition and subtraction. But addition and subtraction are not distributive over what? Multiplication. Take the first one. 2 into 3 plus 4 is same thing as 2 times 3 plus 2 times 4. 3 times 1. And then you get 2 times 3 plus 4 is what? 7. Which is what? 2 times 7, 14. And then 2 times 3, 6. 2 times 4, 8. Then what is 6 plus 8? 14. It will be multiplication is distributive over addition. Timbalo minus B now, you cannot imagine. Timbalo minus B, you cannot imagine. Because if I have minus here, this is going to be what? Minus. Then it might be minus. Then it might be 2 times 2 times minus 1. It might be 6 minus 8. If I'm not mistaken. Yes, 6 minus 8. 2 times minus 1 minus 2. 6 minus 8 minus 2. Well, like I said, multiplication is distributive over subtraction and what? And addition. But to buy can we say I just 2 plus 3 times 4 is equals to 2 plus 3 times 2 plus 4. They are not equal. They are not equal. Olufumage, 2 plus 3 times 4 is 12. 2 plus 4, 2 plus 12, 14. Could they ever get 2 plus 3, 5 times 2 plus 4, 6, which is what? Not equal to 30. You didn't have to say addition and subtraction are not distributive over what? Multiplication. But multiplication is distributive over addition and subtraction. Can I create identity element? Identity element. Given a non-empty set S, which is closed under a binary operation asterisk, for A, comma B to be a member of S, if there exists another element E, which is also a member of S, if A asterisk E equals to E asterisk A is equals to A. Ìtumọ̀ ẹni pé ó perform operation pẹ̀lú nǹkan ó wá fún ẹni kan padà. For example, the voice of your mother, ohùn ìyá rẹ, even if your mom tó wà ní far away tó bá tán sọ̀rọ̀ báyìí ó ti gbọ́, because ohùn yẹn jẹ́ identity wọn. And your school uniform is your identity. Ó wọ́n ní ṣùgbọ́n kò yẹ padà. Ó wọ́n ní. So if you pick any element, you perform operation with the identity elements. Ó máa fẹ́ ní element yẹn padà. If the commutativity, like you pick the first element, operation, the identity element, or you come identity element, or the operation all of an element here. so nǹkan tó bá fọ́ọ̀mù mọ́ ìyẹn tó fi fún ẹ ní evidence yẹn padà fún àpẹẹrẹ kí ni identity element. Fún àpẹẹrẹ 2 positive plus yes 0 is identity under positive. For example, 2 plus 0 2 is same thing as 0 plus 2, which is 2. 10 plus 0 is same thing as 0 plus 10, which is 2 here, and which is what? Which is 10 here. So divide connect under addition, but kò lè ṣẹlẹ̀ under multiplication. Lóòótọ́ 2 minus 0 torí pé kò yí ṣe 0 minus 2 a lè rí yí padà. Òun láti sọ pé 0 is not identity element under what? Subtraction. Is only identity element under what? Addition. What of multiplication? 1 is identity element under multiplication. 1, for example, if I say 3 times 1 is same thing as 1 times 3, which is 3. So the people leave it. 5 times 1 is same thing as 1 times 5, which is what? Which is 5. Torí kó fún wa ní nǹkan yẹn padà láti pè ní identity element. Kò lè ṣẹlẹ̀ lórí division. Tí máa sọ pé 5 divided by 1 is not the same thing as 1 divided by 5. Torí pé àyè rí yí padà yẹn, ó ní 1 kì í fi sí identity element lórí kíni? Lórí division. So what of inverse elements? What is inverse element? Given a non-empty set S, which is closed under a binary operation as stated, for A, B to be a member of X, if there exists another element, let us say A raised to power minus 1 or A inverse, it also belongs to X. Then if A asterisk A inverse equals to A inverse asterisk A, which is equal to E, then we're going to say our A inverse is this A raised to power minus is the inverse element. Nǹkan tá à ń sọ ni wípé almost element kan ó perform pẹ̀lú nǹkan kan wá lọ fún ẹ ní identity nǹkan yẹn. Nǹkan tó perform ẹ̀mọ́ lórí yẹn tó fi lọ fún ẹ ní identity yẹn ò là ń pè ní inverse. But note that this thing is not necessarily to be 1 over A. A kàn fi ṣe symbol ni. Ìgbà míì ó lè jẹ́ 1 over A. But normally a ti mọ̀ pé in indices A raised to power minus 1 is 1 over A. But here it is not necessarily to be 1 over A. It's the symbol of what? Inverse. It can also be X asterisk X inverse is equals to X inverse asterisk X, which is equals to E. So fún àdáyé element yẹn, nǹkan tó ń ta perform mọ́ tó fi fún àdáyé element wọn àpè nìkan inverse. Fún àpẹẹrẹ minus is the inverse of addition. Minus, for example, minus 2 as of example 2 plus 0 is equal to 0 plus 2, which is equal to what? Which is equal to 2. Tí máa sọ wípé kí ni inverse? A jẹ́ 2 plus minus 2, which is same thing as minus 2 plus 2, because of what is 0. Torí pé minus 2 yìí ó la perform nǹkan kan tó wá fún wa ní nǹkan tó jọ mọ́ identity under plus. So our minus 2 is the inverse of what? Is the inverse of 2. What is the multiplication now? 3 times 1 is equals to 1 times 3, which is equals to 3. So division, only say that 3 times 1 over 3 is equals to 1 over 3 times 3, which is equals to 1. So divide eléyìí fún wa ní